What's up, everybody? Welcome back. Patrick here. Moving on to the next question. We have to factor these four expressions here. Now, factoring, a lot of the stuff in this section is going to be review from the previous grade, but there's going to be a lot of new stuff as well. So I'm going to try to do as many examples as possible. So starting off with the first question, we got 6x squared minus x minus 15. So notice that we are dealing with a quadratic here, and we have to factor it. Now, the first thing you want to check for any expression is, can you take anything out? Can you take any numbers out? Can you take any variables out? Well, you can't take an x out because the 15 doesn't contain an x, and you can't take out any numbers either. So what we're going to have to do is we're going to have to factor this by decomposition. So to do a little review, if you remember, if you have a quadratic in ax squared plus bx plus c form, the a value in this case is what? It's 6, the b value is -1, and the c value is -15. So knowing this, you need to find two numbers that multiply to a times c. So 6 times -15 is -90, and add up to the b value, which is -1. So what two numbers satisfy both of those requirements? Well, -10 times 9, because -10 times 9 is -90, and -10 plus 9 gives us -1. So once you have those two numbers, sometimes this process is going to take you a little longer, especially if these numbers are bigger and more complex. But the more you do, the quicker this process will be. So what you do once you have those two numbers is you rewrite this expression, but you decompose that middle term to those two numbers. So you write 6x squared minus 10x plus 9x minus 15. So that's why this process is called decomposition. It's basically because we're taking that middle term and decomposing it into two other terms. So -10x plus 9x gives us -1x. So this here is the same as that up there. The first and the last terms stay the same. The middle term we are just decomposing. Now, there are multiple ways to factor quadratics, so you may use something called the cross method. Your teacher may show you a different method. Personally, I like using this method most because once you start dealing with bigger numbers, the cross method gets a lot tougher to use. Other methods start getting tougher to use. But this method works every time. It's always reliable. Right? So I'm decomposing that middle term to -10x plus 9x. And then what I'm doing is I'm going to factor by grouping. So I got to take out something from these two terms. What can I take out from 6x squared minus 10x? Well, I could take out a 2x. And if I take out a 2x, so 6x squared divided by 2x would give us what? It would give us 3x minus, what's 10x divided by 2x? That's just 5. Right, so I took out a 2x from these two terms, and I'm left with 3x minus 5. And then I want to take out something from these two terms. What number can I take out? I could take out a 3. And then I would be left with 3x minus 5 as well. 9x divided by 3 is 3x. This minus goes here, and then 15 divided by 3 is 5. And when you get to this point, these two brackets, you may want to write a note here, should always be the same. These two brackets here. Right? And if they're not, then you know you did something wrong. Whether you got the wrong numbers there, or maybe you factored wrong, so you factored incorrectly from these two or these two. Whichever it is, these two brackets should always be the same if you're doing it correctly. And then at this point, what you can do is you could take out this bracket from each of these two expressions. So you pretend like this bracket's a number. So I take out 3x minus 5, and then I'm left with 2x plus 3. And that there is the answer. That is this factor. So we took this and put it into two expressions multiplied by each other. So that's the answer. So let's write that up here. 3x minus 5, 2x plus 3. Now you can also check your answer. The way you could check is you can FOIL these out. So you can multiply them out, and if we end up getting that same expression that we originally started with, you know that you factored it right. So 3x times 2x is 6x squared. 3x times 3 is 9x. 2x times negative 5 is negative 10x. And then negative 5 times 3 is negative 15. All right, so notice these two middle terms. It ends up being these two middle terms that we had before, right? Positive 9 and negative 10, positive 9, negative 10. And then the middle terms are like terms, so they simplify to negative 1x. And then we have the minus 15. So that and that are the same. So that's how you could check. If you have time, you can expand everything. Make sure you get your original expression. So that is the answer to number 1. Moving on to the second question, we have to factor 24x cubed y plus 54x squared y squared minus 15x y cubed. So first thing you check is, can you factor anything out of all of the terms? So starting with the numbers 24, 54, and 15, notice out of all of those, greatest common factor we could take out is 3. And then notice that all of these expressions, they all contain the variables x and y. So what you want to do is you want to factor out the lowest exponents for each variable. So notice that x, here we have x cubed, x squared. This one is x to the power 1. So out of all of those, which is the lowest exponent, x to the power 1. So that's the one we could take out. And then y, we have y to the power 1, y to the power 2, y to the power 3. Out of all of those, we could take out y to the power of 1. That's the lowest exponent. So if we take out 3xy, what are we going to be left with? Well, if we divide this by 3xy, 24 divided by 3 is 8. X cubed divided by x to the power 1, when you're dividing exponents with the same base, you subtract the exponents. So 3 minus 1 gives us 2, and then y over y, those cancel out. And we have plus here. If we divide this by 3xy, what would we be left with? 54 divided by 3 would give us 18. X squared divided by x to the power 1, subtract the exponents, then we're just left with x to the power 1. And then y2 divided by y to the power 1, that would just give us y to the power of 1. And then minus, dividing this by 3xy, 15 divided by 3 is 5. The x's here cancel out because they're both x to the power 1. And then y3 divided by y to the power 1 is y squared, like that. So we took out a 3xy and we're left with this bracket here. And then what we want to do is we want to check if we could factor this bracket further. So what I'm going to do is I'm actually going to take this bracket and rewrite it down here. So I'm going to factor it on the side. And then we'll come back to the overall expression after to summarize it. So this is 8x squared plus 18xy minus 5y squared. So even though there's another variable y here, notice this is like a quadratic, so we're still going to be factoring this with decomposition. So notice the a value in this case is 8. The b value is 18, and then the c value is negative 5. So what we want to do is we want to find two numbers that multiply to a times c. So 8 times negative 5 gives us negative 40, and add up to the b value of 18. So what two numbers would satisfy those two requirements? Well, it would be positive 20 and negative 2. because 20 times negative 2 gives us negative 40, and 20 plus negative 2 is like 20 minus 2, which gives us positive 18. So what we do is we now decompose that middle term to those two numbers. So 20xy minus 2xy minus 5y squared. So the first term stayed the same, last term stayed the same. This middle term we just decomposed to 20xy minus 2xy, which is 18xy. And then what we want to do, we want to factor out of these two. What can we take out of these two? We can take out a 4x, because 4x can go into both. So 8x squared divided by 4x would give us 2x. And we have a plus here. And then 20xy divided by 4x. 20 divided by 4 is 5. The x's cancel out, and we're just left with a y. So 2x plus 5y is remaining there. And then from these two terms, what can we take out? Now, whenever this here is a negative, right? So the first term in that second set, you know that what you're going to be taking out is always going to be a negative. So we could take out a negative 1, right? 1 goes into 2 and 5, and we can also take out a y, because both of these terms contain the variable y, and we could take out the y with the lowest exponent, which is y to the power 1. So we'd be taking out minus y from both of these. So negative 2xy divided by negative y gives us positive 2x. Then negative 5y squared divided by negative y gives us positive 5y. And once you get to this step, remember this bracket and this bracket, they should always be the same. If they're not the same, then you know you did something wrong, right? And if they are the same, what you can do is you can factor out that bracket. And what would we be left with? 4x minus y. So this expression here factors to this expression there. So now going back to our original, we got 3xy, and then this bracket we factored into these two brackets. So we got 2x plus 5y, and then 4x minus y. So this here we can rewrite 3xy, 2x plus 5y, 4x minus y. All right, so a little bit more complex. I know it seems complex at this point, but the more practice you get, the more automatic it's going to become. And you're going to get tons of practice in this chapter. I'm going to have tons of questions on this stuff in the lectures and on the mock tests. Plus, you have questions from your class and in your textbook. All right, so that is how you do the second one. Moving on to the third question, I rewrote it up there. And if you wrote this down before doing it, before I had x plus 3 in both these brackets, and I changed them to x minus 3 and x minus 3. So if you can just make that correction there. So we have 2x squared bracket x minus 3 minus 11x bracket x minus 3 plus 6 bracket 3 minus x. So notice in all of the expressions, we almost have all of them containing x minus 3, except for this one here. This is 3 minus x. But notice we could change it to be x minus 3 if we factor out a negative from that bracket. So if we rewrite all this, we got 2x squared bracket x minus 3 minus 11x, x minus 3. If we take out a negative from this bracket, this positive 6 turns into minus 6. And then this would end up being negative 3 plus x. So basically all of the signs would change. We took out a negative 1. Positive 3 divided by negative 1 is negative 3. Negative x divided by negative 1 is positive x. And then negative 3 plus x, we could just rewrite that as x minus 3. And now notice that each of these three expressions contain the expression x minus 3. So we can factor that out. we could factor x minus 3 out. Now, what about the remaining expressions? 2x squared minus 11x minus 6. Can we take anything out of those? There's no numbers we could take out. There's no variables we could take out. So we would just rewrite them in a bracket as they are. 2x squared minus 11x minus 6. Right? So we factored out the expression x minus 3. Before we were able to do that, though, we had to take that 3 minus x, factor out a negative for it to be x minus 3, and then we were able to take it out. You can't take it out beforehand because it's not x minus 3. So now we have these two brackets remaining, and we want to check if we could factor further. So notice we have this quadratic here. So I'm going to rewrite that down here, 2x squared minus 11x minus 6. You want to check if you could factor this. So we know the a value in this case is 2, the b value is negative 11, c value is negative 6. So you check for two numbers that multiply to a times c. 2 times negative 6 is negative 12, and then add up to the b value of negative 11. So what two numbers satisfy these requirements? Negative 12, positive 1. Negative 12, positive 1. Negative 12 times 1 is negative 12. Negative 12 plus 1 is negative 11. So we would take those two numbers, decompose that middle term. 2x squared minus 12x plus 1x minus 6. What can we take out of these two terms? We could take out a 2x. If we take out a 2x, 2x squared divided by 2x is x. 12x divided by 2x is 6. And then from these two terms here, not much we could take out. If you can't take anything out, you just take out a 1. And we would just be left with that term as is, x minus 6. So notice these two brackets are the same as they always should be, because now you're going to take out that bracket, and what are you going to be left with? 2x plus 1. So this x minus 3 is remaining, and then this bracket I factored into x minus 6, 2x plus 1. So that there is your final answer for number 3. So notice there's 3 brackets in this case. We got x minus 3, x minus 6, 2x plus 1. So the trick in this question is recognizing that you could factor out an expression. You don't always have to factor out a number of variables like we did up here, the 3xy. You can also factor out actual brackets. And all of these contain x minus 3. This one we have to change first. We have to factor out a negative 1 for it to be x minus 3. But once we did that, we were able to take out the x minus 3. Had this bracket remaining, and then you factor that remaining bracket into those two brackets. And then finally, the fourth question I rewrote up there. We got 3 bracket 2 minus x squared plus 4 bracket x squared minus 5 minus bracket 6x plus 2. So first thing you check is, can you factor anything out? Well, notice we can't factor out any numbers. So we have 3, 4, and then over here we have like a negative 1. So nothing we could factor out from there. What about the brackets? We got 2 minus x squared minus 5, and then 6x plus 2. So all those brackets are different. Can't really factor anything out of those. So what we're going to have to do in this case is we're going to have to expand everything, simplify it, and then check, can we factor that remaining expression? So expanding this, we got 6 minus 3x squared. Here we would have 4x squared minus 20, and then we would have minus 6x minus 2, like that. So negative 3x plus 4x squared, that gives us positive x squared. Those are like terms. And then this negative 6x is by itself. And then we got 6 minus 20, which is negative 14. Negative 14 minus 2 gives us negative 16. right? And now we have this simple quadratic, x squared minus 6x minus 16. So let's check if we could factor it. We got an a value of 1, we got a b value of negative 6, we got a c value of negative 16. Two numbers that multiply to a times c, which is negative 16, and add up to negative 6. Do any numbers work for that? Well, negative 8 and positive 2 work. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. So we could decompose that middle term to those two terms like that. What can we factor out of the first two? We could take out an x. We're left with x minus 8. What can we take out of these two? We could take out a positive 2, left with x minus 8. Notice these brackets are the same. They should always be the same. Take out an x minus 8, and we are left with x plus 2. So that is the final answer for this question here. So notice that the final answer is not even as complex as the other questions that we did, even though initially it looked pretty complex. And the reason why it looks complex is because you can get pretty much anything. But if you can't factor anything out, like up here, the 3xy, or up here, that x minus 3, you have to expand everything, simplify it, and then factor that remaining expression. So you pretty much forget about that, and it's like you got this as a question. So then you factor this, simply factors to x minus 8 and x plus 2.